Hi guys, welcome back. In the previous video we have completed the 4 topics: basic Linux commands, basic services to use in Kali machines and service management, and command line fun. So if you guys missed this video, please go and watch this previous video to get better understand. Okay, so now in this video we're going to see bash shell scripts. Bash is a powerful work environment and scripting engine. A competent security professionals will skillfully leverage bash scripting to streamline and automate many Linux tasks and procedures. So introductory to bash scripting. A bash scripting is a plain text that contains a series of commands that are executed as if they had been typed at terminal prompt. Generally speaking, bash scripts have an optional extensions of .sh begin with a bash shebang and must have executable permission set before can be executed. Okay, let's begin with a simple scripting. So I can see here that I have already created the hello bash, the simple scripting, hello bashing.sh. So before that, so I'll show you this file permission now. So this is a simple slide. It's very easy to understand. So when you're seeing this or understanding the Linux file permissions, so D is a directory, or is a read, W is write, and X is executable. So I'm going to use a 777 change mode. Okay, 777. So this is executable mode. So if you guys want to use that only read write, so you guys can use it, and then only read only. So if you want to use only that 444, it's read only mode. Okay, so the change mode along with the 777 options is used to make the script executable. Okay, so now let's see the what we have in the script. On the line 1, the pound sign followed by exclamation mark is commonly known as shebang. Okay, and is ignored by the bash interpreter. So in the second line, /bin/bash is the absolute path to the interpreter, which is used to run the script. That this is what makes this is bash script as opposed to another type of shell script like a C shell script, for example. Okay, on line 2, the pound sign is used to add a command, so all the text that follows is ignored. Okay, on the line 3, echo the thanks to subscribe a gray hat spot is used to echo utility to print a string. Okay, this is a simple script, so it's easy to understand. Let's execute this script now. Okay, so we have already give the permission 777, the change mode 77. So now it's executable mode. So now you successfully executed the script. Okay, so the // notations may seem confusing, but this is a simple path notations indicating that the script is in this current directory. So since our home directory is not included in the path environment variable, so we must use the relative path to our bash script in order for bash to find it and run it. Now what we have created our first bash scripts, let's explore bash in a bit more details. So now we're going to see the variable. Variable or name place to temporarily store data. We can set or declare a variable which assign a value to it, or read a variable which will expand or resolve it to its stored value. So the easiest method is to set the value directly with the simple name equals value declarations. Okay. So notice that there are no space before or after the equal sign. Declaring a variable is pointless unless we can reference it to do this. We proceed the variable with the dollar sign characters. Okay, let's now use the echo command with dollar character, sign character. Okay. Echo and then dollar first name and then last name. So now you guys can see here. So whenever bash encounters this syntax in a command, it replaces the variable name with its value before executions. Variable names may be uppercase, lowercase, or a mixture of both. However, bash is case sensitive, so we must be consistent when declaring and expanding variables. In addition, it is good practice to use descriptive variable names, so which makes our scripts much easier to read and maintain. Be advised that bash interrupts certain characters in specific ways. So there is one more example, the best example. Let's see that. Declaring a variable is pointless unless we can reference it. So to do this, we proceed the variable with the dollar sign characters. Whenever bash encounters the syntax in a command, it replaces the variable's names with its value before executions. Variable names may be uppercase, lowercase, or mixture of both. However, bash is case sensitive, so we must consistent when declaring and expanding variables. In addition, it's a good practice to use descriptive variables names, which makes our script much easier to read and maintain. Be advised that bash interprets certain characters in specific ways. For example, these declarations demonstrate an improper multi-value variable declaration. So this was not necessarily what we expected. To fix this, we can either use single or double quotes to enclose our text. However, bash treats single and double quotes differently. When encountering single quotes, bash interprets every enclosed character literally. When enclosed in double quotes, all characters are viewed literally except the $sign backtick and backslash, meaning variables will be expanded in an initial substitute pass on the enclosed text. Let's see a few examples. The simple example will help clarify this. First, we will declare and expand a variable using single quotes. Oh, sorry. So I'm going to remove this. Okay. So in the example, the single quotes and enclosed declarations of greeting preserved the exact value of our text and didn't interpret the space as a command delimiter. Okay. So now we can also, now let's declare a variable with double quotes. In the double quotes enclosed declaration. Okay. So declarations of greeting to bash expand the greeting value to its value of hello bashing, honoring the special meaning of the $sign characters. We can also set the now we can check the echo. So now you guys can see here the result. We can also set the value of the variable to the result of a command. Here we are assigning the output of who am I command to the user variable. Let's try displaying the value. So let's now an alternative syntax for command substitution is to use a backtick or grave characters. Okay, the backtick method is older and typically discouraged as there are difference in how the two methods of command substitutions behave. It is also important to note that command substitutions happens in subshells, and change to variables in the subshells will not alter variable from the master process. Let's demonstrate this following example so you guys can see here. In this example, note that we have changed the shebang, adding in the dash x flag. Okay, so here okay, now let's execute. So we can more easily see the commands that are executed and the results. As we view this output, notice the command proceeded with a single plus sign were executed in the current shells, and commands proceeded with the double plus sign were executed in the subshell. So this allows us to clearly see that the second declarations of variable 1 and variable 2 happen inside a subshell and didn't change the value in the current shell as the initial declaration did. Okay, now let's see arguments. Argument not all bash scripts requires arguments, but it's extremely important to understand how they are interpreted by bash and how to use them. We executed Linux commands with the argument. For example, we can run ls-l/var logs both slash. Okay, so now the bash scripts are no difference. We can supply the command line argument and use them in our scripts. Let's create a simple script now. argument.sh. Okay, so the $1 and $2 variable represent the first and second argument passed to the script. Let's execute this script now. We have to check this. Let's give our script executable permissions, run it while providing 2 arguments. So when you execute without the string, so you get nothing. So when you execute with the argument, the string hello and there, so you guys can see here. Okay, as expected, our script runs and bash echoes the 2 arguments we provided. Hello or there is displayed in the result, the output. There are number of other special bash variable. Echo, like $question marks to display the exit status of the last process, and $random, which generates a random number. So just Google it to know more about the special bash variables that you can use it in your scripts. Okay, next, reading users input. Command line arguments are a form of user input, but we can also capture interactive users input while the script is running with the read command. So in these examples, we will use read and capture user's input and assign it to answer variable. Okay, let's create a simple command, the input shell. Okay, so now we can just give you permission to execute more. So we can now set change mode 77. So let's execute the script now. So before that, let's see here. So this is a script what I created, the simple script. So the read and then read answer and then echo your answer was the variable. Okay, we can alter the behavior of the read command with the various command line options. So let's run this, let's execute this command now. Input. So let's execute now. So when you press X, so you get this, your answer was Y, your yes. So let's create another example. So as I said before, we can alter the behavior of read command with various command line option. Okay, two of the most commonly used options include -p, which allow us to specify a prompt, and -s, which makes the user input silent. The -s option is idle for capture user credentials. Okay, so the -p here, so we have created, let's save it. Okay, done. Control X and then yes. Okay, now we can see the permissions. Change input to .sh. So let's execute this script. So notice how the -s option hid the password as it was entered, the username and password. Okay, you can also try with a different name. Okay, try with this different password. Okay, so let's see now if else and if statements. Conditional statements allow us to perform different actions based on different conditions. The most common conditional bash statements include if else and if. Okay, else if in short is if. The if statement is relatively simple. It checks to see if a condition is true, but it requires a very specific syntax. So pay careful attention to the syntax, especially the use of required space. Okay, so let's see the example. Let's create the simple example, the if statement. Then later we will see else if statement, the conditional statements. Okay, so in this example we use the the simple scripts, the sample scripts. We use an if statements to check the age entered by a user. If the entered age is less than 16, the script will output a warning message. Okay, so let's save this script now. Okay, let's make this script executable and try here. So great. Let's see now. Okay, great. So our age checks is working correctly. Okay. So the square bracket we used in the if statement are actually a reference to the test command. This means we can use all the operator that are allowed by the test command. You can Google it to know more about some of the variable operator. With this in mind, our previous example use if can be rewritten without square bracket as follows. Even though this example is functionality equivalent to the one using square bracket, the square bracket makes the code slightly easier to read. We can also perform a certain set of action if statement is true, another set of if it is false. Let's see now, just remove the square brackets. With this in mind, our previous example using if can be rewritten without square brackets as follows. So I just remove this bracket. Even though this example is functionally equivalent to the one using square bracket. Okay, let's run this. Change the, make it executable. Okay, so as expected, so it works perfectly. Let's extend our previous edge example to include the else statement. Okay, now let's add the else. So in this script, if the entered age is 16 or over, a welcome message will be displayed. Sorry, there's a small typo. So let's save it. So let's execute this. Let's run the scripts and make sure it works as expected. Let's run the script now and make sure it works as expected. So notice the else statement was executed, and when the enter age was greater than, less than, and greater than, so notice that the else statement was executed when the entered age was greater than or more, specifically not less than. The ifs and else statement allow only two code execution branches. We can add additional branch with the else statements which uses this syntax. Let's extend our age examples again to include the else statements. So just adding this sample elf, so this is a script, elf script. Just going to add the elf, elif, So in this example, the code execution flow is slightly more complex. In order of operation, the then branch executes if the enter age is less than 16. The else if branch is entered and the awesome hats off to you respect, this displays. And then if the age is greater than 60, and else branch executes only if the age is greater than 16 but less than 60. Okay, so let's execute the script. Okay, so it's less than 16. So you can see here that it displays you might need parental permission to watch the video, and then when you enter the age above 60, so you can see that awesome hats off to you respect. And then when you entered between 16 and 60, so you can see here this string is displayed. Okay, let's try the latest scripts and see if it works. Great, now we have a frame grasp and conditional statement in bash. Now let's see Boolean logic operators. Boolean logical operators. Boolean logical operators like and or are somewhat mysterious because bash uses them in a variety of ways. One common use is in command list, which are chains of commands whose flow is controlled by operators. The pipe symbol is commonly used operator in a command line and passes the output of one command to the input of another. Similarly, Boolean logic operator executes commands based on whether a previous command succeeded, meaning it returned true or 0, or failed by returning false or non-zero. Let's take a look. So let's create a simple script for AND operator first, which execute a command only if the previous command succeeded or return true or 0. Okay, let's see now. So in this example, we first assign the users we are searching for to the user to verify used this way, and combines. Next we use a check for a circuit. The branch will be executed. Okay, so let's make this script execute. Okay, it's done. So now you can see it appears to have worked. Okay, so let's move on to the OR operators. So let's create the simple script for OR operators. So when used in a test, the OR operator is used to test one or more condition, but only one of them has to be true or count as a success. Let's look at the example. In this example we use to test multiple conditions. Okay, when used in a test, the OR operator is used to test. So one or more conditions, but only one of them has to be true to count as a success. Let's look here. Okay, so it's displayed now, since one of the variables comparisons was true. So the whole if line succeeded to the then branch executed. Okay, now let's see loops. In computers programming, loops helps us with the respective task that we need to run until certain criteria is met. In Bash, the two most predominant loop commands are for and while. We will examine both. First we will see for loops. So in this batch one-liner we use a sequency command to print a sequence of numbers. In the case the number 1, through each number is then assigned to the IP variables, and then each IP address is displayed to the screen as the loops runs multiple times, executing at the end of the sequence. Okay, let's see another way of rewriting the previous for loop. Involves brace expressions using range. So let's run this. Just replace these brace expressions. I just replaced this brace expressions and then modify it slightly. Let's run this. So now you guys can see here. So with the brace expressions using range, we supply the first and last value of the range. So this can be sequence of number or characters. This known as sequence expressions. There is a lot of potential for this type of loop. Displaying IP address to screen may not seems very useful, but we could use the same loop to ping each IP address, run a port scan using nmap, etc. Next we will see while loop. So while loops are also fairly common and execute code while an expression is true. While loop have a simple format, unlike if statements. If statement use square brackets for the test. Let's re-examine the previous example and rewrite it using a while loop. Okay. So our script gives the counter variable the initial value of a 1, then as long as the counter variable is less than 10. The IP address is printed to the screen. Okay, let's make it executable mode. Let's make the script executable modes. Okay, now let's run the script and see what we get. This is not the output. So this is not the output we expected. It is due to the common mistakes called an off by one error. Okay, so we can see only 1 to 9. It's supposed to comes up to 9, 192.168.0.10. In our script we use the less than operator -lt, as you guys can see here, instead of less than or equal to -le. So in our script we use the less than operator -lt instead of less than or equal to -le. So our counter only got to 9, not as originally intended. So the counter plus lines use the double parenthesis construct to perform arithmetic expansions and evaluations at the same time. In this particular case we use it to increase our counter variables by 1. Fixing our scripts requires one minor changes. We simply need to change it to use the less than or equal to operator. Okay, let's go and change this. Okay, I'm going to replace it e, so less than equal to. So let's save it now. So now let's execute this again. So good, our while loops works quite well now. So now you guys can see here. So 192.168.0.10. Functions. In terms of bash scripting, we can think of a functions as a script within a script, which is useful when we need to execute the same code multiple times rather than rewriting the same chunk of code over and over. We can write it once as a functions and then call that function as needed. Put another way, a function is subroutine or a code block that implements a set of operations, a black box that performs a specific task. Functions may rewritten two different formats. The first format is more common to bash scripts, and the second format is more familiar to C programmers. The formats are functionally identical and are matter of personal preference. Let's create a simple example. Okay, the simple script I'm going to create now. Functions. Okay, let's save it. So give your permission to execute. So in this script we declare a function called printme that simply echoes a lines to the screen. We then call the functions by its name to execute it. Functions can also accept arguments. So let's create that. Argument 1. Okay, so now it's created. So in this case we pass a random number into the functions, which outputs it's a $1, the function's first argument. Note that the function's definitions contains parentheses. In other programs language such as C, this would contain the expected arguments, but in the bash the parentheses serve only as decorations and are never actually used. Also note the function's definition must appear in the scripts before it's called. Logically, we cannot call something we haven't defined. Let's run the script to verify that it works. Change mode. Okay, perfect. In addition to passing arguments to bash function, we can return value from them as well. Okay, bash functions do not actually allow you to return an arbitrary value in the traditional sense. Instead, a bash function can return an exit status like 0 for success and non-zero for failure, or some other arbitrary value that we can later access from the $? Global variable. Alternatively, we can set a global variable inside the functions or use command substitute to simulate a traditional return. Let's see the basic example. Return a random number into $? So this is a simple script. So let's save it. So let's make it executable format. So give a permission 77. Okay. So executable. Notice that a random number is returned every time we run the script. This is because we return the special global variable $random into $question mark. If we use the return statements without the $random arguments, the exit status of functions, which is 0 in this case, would be returned instead. Now that we have a basic understanding of variable and functions, we can now dig deeper and discuss variable scope. The scope of a variable is simply the context in which it has meaning. By default, a variable has a global scope, meaning it can be accessed through the entire script. In contrast, a local variable can only see within the function's block or block of code or subshell in which it is defined. We can overlay a global variable, giving it a local context by preceding the declarations with a local keyword, leaving the global variable untouched. Let's see how local and global variable works in practice with a simple example. Okay. So let's create this script now. Okay. M2 is name 2. Let's save it, then open that cat. Yeah. First note that we declare two global variable settings, name1 to Bob and then name2 to Mike. Then we define a functions, and inside the functions declares a local variable called name1, setting the value to Edward. Since this is a global variable, the previous global assignment is not affected. Name1 will still be set outside these functions. Next, we set name2 to locus. Since we didn't use the local keyword, we are changing the global variable, and the assignment sticks both inside and outside of the functions. Let's run this script to see it in action. Okay. Sorry. Yep. So let's make it executable. So now execute now. Yeah. So based on the example, we know that changing the value of local variable with the same name as a global one will not affect its global value. We have also verified that changing the value of a global variable inside of the functions without having declared a local variable with the same name will affect its global value. Okay. So now let's see the practical examples. Practical examples. So far we have covered the basics of bash scripting. Let's put together all the concepts we have discussed and walk through a few practical examples. Practical example 1. In these examples, I'm going to use a website called f-secure.com. It's for demonstrate purpose only. So we will see how to find all the subdomain listed on the main website f-secure to find their corresponding IP address. Doing this manually would be frustrating and time consuming, but with some basic bash commands we can turn this into an easy task. So we will start by downloading the index page with wget. So the index page is downloaded successfully. Now you guys can see here the index.html is downloaded. Let's check this using a less command, the manual scanning. So manually scanning the file, we see many lines we don't need. Okay, so let's narrowing in on line that we need and strip out lines we don't. First, this is the example commands. So one of the best example. The first part, the first one, so grep to extract all the lines in index.html that contains HTML links by searching for href equals. Okay, and the next one, this grep to grab lines that contain dot f-secure indicating the existence of a subdomain, and grab -v to strip away lines that contains the boring www subdomain. Okay, and then we will use this -F options of awk to set multiple characters delimiter. We will set our delimiter to https :// we then tell awk we want the second field or everything after our delimiter return. Okay, and then cut to set the delimiter to a / and print the first field, leaving us with only the full subdomain name. So let's run this. So after run this script, so we have managed to get all the subdomains from the main website. So this is what we are looking for in the first place. Now next we will check this IP address, how to get the IP address. Okay, so a well-formed regular expression search can handle this scenario easily. This solution is quite compact, but it introduced some new techniques. So first, notice the grep -o options, which only return the string defined in our regular expressions. The expressions itself looks complex, but it's fairly straightforward. The string we are searching for it is wrapped in single quotes, which as we mentioned will not allow variable expansions and will treat all enclosed character literally. The first block in the expression is negated set the search for any numbers of characters not including a /. Notice that periods are escaped with a / to reinforce that we are looking for a literal period. Next, the string must end with a f-secure.com. With grep finds a matching strings, it will curve it from the line and return it. Now let's run this script. So now it's saved it on the list.txt. So when we open that using the cat command, so you guys can see here, now we have a nice clean list of domain names linked from the front page of f-secure.com. We could have done more with these regular expressions, but it is great start and good example of why regular expressions are so valuable. Okay, so next we will use the host command to discover the corresponding IP address of each domain name in our text file. We can use a bash one-liner loop for this. The host command gives us all sort of output and not all of it relevant. Let's use this command now. Okay, so we will now extract the IP address by piping the output into grep for hash address. So let's clear. Okay, Now I'm going to add the grep has address. Okay, then pipe, then cut the result, and okay, you have to use this command to cut the result and sort them. For that you need to use sort-u. Nice. So we have extracted that .f-secure.com subdomains from the web page and obtained the corresponding IP address successfully. Okay, so now let's see that example to bash a practical bash usage example 2. Practical bash usage example 2. In this example, let's assume we are in the middle of the penetration test and have unprivileged access to a Windows machine. As we continue to collect information, we realize it may be vulnerable to an exploit that we read about that begins with the letter A, F and D, but we cannot remember the full name of the exploit. In the attempt to escalate our privilege, we want to search for the specific exploits. To do this, we would need to search exploit-db for AFD Windows download the exploits that match our search criteria and inspect them until we find the proper one. We could do this manually through the website, which wouldn't take too long, but if we take this time to write a bash script, we could easily use it to search for and automatically download exploit later. Using what we know about scripting, let's try to automate this task. So we will start with the search-exploit utility include with callee. So we will start with search-exploit utility included with the callee. Search-exploit is a command line search tool for exploit-db that allows us to take an offline copy of exploit database with us whenever we go. We will pass AFD Windows as a search string, use -w to return the exploit db URL rather than the local path, and -t to search the exploit title. Okay, so let's execute. So this is a good start, but we need to trim the result. For now we are only interested in exploit URL, so let's grab for HTTP and then cut what we need. We will use a pipe field delimiter and extract the second field. Okay, let's execute. So that looks better now. So now that we have the URLs for each exploit, so we can use a bash loop to download the files and save them locally. So let's copy the URL. Okay, so let's open it, Firefox. So this exploit code is very important. So when you're searching something, okay. Okay, practical bash usage example 3. As penetration testers, we are always trying to find efficiency to minimize the amount of time we spend analyzing data, especially the volume of data we recover during various scans. Let's assume we are tasked with scanning a Class C subnet to identify web servers and determine whether or not they present an interesting attack surface. Port scanning is the process of inspecting TCP or UDP ports on a remote machines with the intentions of detecting what services are running on the target and potentials what attack vectors exist. We will discuss port scanning in much more details in another video. But for now, let's keep it general, as this is a great examples that shows how bash scriptings can automate a rather tedious task. In order to accomplish our goal, we would first port scan the entire subnet to pinpoint potential open web services. Then we could manually browse their web page. Let's begin. Let's create the temporary folder. Then cd into it. Now let's move on to the interesting part. A scan of the Class C subnet. We will only focus on port 80 to keep the scope somewhat manageable, and we will use nmap of our port scanning tool. So this is pretty straightforward. Scan with a -A for aggressive scanning, -P to specify the port or port range, and then --open to only returns machines with open ports. We will also include -OG to save the scanned result in crappable format. Okay, so this is a scanning report. Okay, nmaps certainly provide a decent amount of output to work with. Okay, so with these results, I don't have much IP address. That's why you don't get the samples, the good samples. Sometimes you can see that the IP address is showed twice. So this kind of information you can see here. Okay, so let's see how to grab the port number. Okay. Yeah, okay, so this is only IP address. I have only one machine, that's why it shows one IP. So if I have 4 or 5 machines, it shows the IP address. Anyway, that's it, guys. Okay guys, we have completed the chapter 1, getting comfortable with Kali Linux for pen testings. So I hope you guys enjoy this video, the bash shell script. So the upcoming topics is a practicing hackers tools. Please subscribe my channel, press the bell button to get more updates, share the video to your friends, guys. Have a good day. Bye bye.